group, and this was the group that was responsible for the production of children, the prime child-rearing years. If we were to trace this out, so 15 years later, we need to then monitor where these members eventually end up. So it takes 15 years to 20 or 25 or 30 years to find out where exactly your population is growing. Because we don't know how many children the current children are going to have when they're a prime child-rearing years. Does that make sense? Yes or no? Clear as mud? All right, your lack of response means either you're comatose or you're okay with it. So, all right, so that's the demographic momentum. I like to think of it like a wave. Powerful wave coming in. You don't know that until it starts to hit the land and starts to rise up. It takes time for that to occur. Same thing happens here. So from a population geographer perspective, understanding population growth takes time because you've got to be able to track it out, 15, 20, 25 years at a time in order for you to kind of really to understand it. So we don't totally know where population issues might be, maybe for another 20 to 25 years. Because we don't know what today's current children are going to do when they become adults and they have children. Okay. So, policies. 3 different types. Okay? 1, expansive, have more kids. When you have ZPG, zero population growth, or if you have more emigration than immigration, you're going to encourage them to have more children. Have a child, have money. My story, I think I told my students is, in Russia they had a town where basically if you had a child on a certain day, they'd give you a car. So guess what? Population increased by about 300% over what it had been the year before, during that same time period. Okay? That's called an expansive policy. Ways to expand the population. Restrictive policies. Ways to try to limit the population. Best example of that, if you have any question about it, China's one-child policy. I just want you to note with that has changed over the course of time. The one-child policy applies to the urban areas, especially in eastern China, but they don't apply to the agricultural regions of the rest of China. Oftentimes we think of it as a universally applied principle to all of China. That's not the case. Right, so don't screw that up. All of China doesn't experience the one-child policy. It's the urban areas. You can also talk about birth control and provided birth control. And Massachusetts was on the record recently for giving out contraceptives to preteens. Okay, that's an example of a restrictive policy to try and limit population growth, especially in the teenage population. Abstinence education. Okay, just don't have sex. But those are policies as they're pushed by the government that are considered restrictive. And then the third and final one is kind of the most extreme form, which is eugenic. Think of eugenic as kind of selective population. You favor a particular cultural group. And so perhaps, I knew it was going to do that. It happened last time too, didn't it? I don't know how to get past this. I have to do something. I don't know what I'm going to do. I'm going to throw this thing out the window.
You hit it really hard, it probably would.
I think I could, but it would probably hit you if I hit it back. I know you, so if I hit it. Now all my students are around. I got to hit it really hard in that back corner. I don't know any of you. All right. No, we'll let that heat back out or cool down, heat back up. Talking about eugenic population policies, you're talking about policies that basically restrict certain groups from expanding. So oftentimes it's gone after those that have any sort of special needs. So like those, it's a Down syndrome child, for instance. Some governments have pushed that if you know ahead of time it's going to be have some sort of special need, that you need to destroy the child before you can have the child. That's considered eugenic. Nazi Germany, best example of that, where you have selective breeding, okay, the blonde hair, blue-eyed sort of ideal that existed in Nazi Germany. All right, take a second. Stretch out your neck. Ooh, next slide, really important. Okay. Questions so far while we wait for that thing? I will figure this out before next Tuesday, so this doesn't happen. Questions so far? That's what you get. Yes, no? No, I talk like a million miles a minute, so maybe it's good. Those of you guys who went to Mrs. Buccarelli's earlier, am I going faster than her? Yeah? Good.
It's a race.
Yeah, it is a race. You only remember like 30% of what I say. So if I say more, you'll remember more.
This is really just staring at the kids right now. Will you answer my question? There's 5 minutes, so sometimes it goes really slow.
Well, I don't really care what you know. I'm telling you what I know. All right.
It doesn't care what you know, Tommy.
Aha. Okay. Super important slide. Now, a way to measure population. The way to do that is doubling time. We have had questions in the past, the multiple choice test, that gives you a doubling time question. You got to be able to figure out the math. You cannot use a calculator on the AP test, so they're going to give you a question that basically you could solve through just your own multiplication or division skills. You should also reasonably infer where it's going to be between two numbers. In most cases, you can do that. All right, doubling time is the amount of time for our current population to double. You can do it at any scale. We do it with the global population. We could use the U.S. population. We could use Algro's population. All right, we can apply it to any scale, and sometimes it's more successful than others. It's not an absolute, because things change in the course of time, which affect our growth rate. However, it's a rule of thumb. So, if, for example, Canada, which, by the way, they have 33 million people. Where the heck did they live? Okay, so there's 33 mooses in Canada. There's 33 million Canadians, which is 33 million too many. Okay, I'm done with Canada. 33 million Canadians. If their growth rate is 0.9%, you take 70. Why 70? Log of something, and they did the math, and I don't care. Use 70. 70 divided by your growth rate as a percent. And that's going to get you into a number. That's the number of years that it takes. Obviously, you add it on to, in this case, today's date. And then by 2090, Canada's population will double to 66 million people. Just confirms our desire or need to invade. So, that's doubling time. Just good rule of thumb. Now, we also know that the Earth has limits, and that's the second part of this slide. If we were to look at population growth, the natural shape of it, without restriction, is a J. Thus, it's called a J curve. This basically says that your exponential growth is going to go unchecked. We know it can't happen. The Earth is finite, which means that it has limits. And those limits create a different phenomenon, but one that we don't know. Right now, we're somewhere in here in terms of the J. It's still growing. We haven't hit our top yet. The prediction is, though, at some point in time, we're going to reach the ceiling. Much like if you're climbing this room, eventually you hit the ceiling. Right? Same too is going to happen for population. What that creation is then is a really ugly S. Now I had a C in writing, so that's about how I would write an S, but you get the idea, okay? So it's going to create that, it's going to level off the top of that J, and what's going to happen there is we're going to hit what we call our carrying capacity. Now, super interesting, carrying capacity. All these different numbers have been tossed out there based upon all these different theorems and whatnot. They crunch a bunch of numbers. A bunch of people that are in universities who don't actually do anything, right? They throw out these numbers. 240 billion people. What's our population right now? 7. So there are some geographers who say that we've actually exceeded our carrying capacity. And at some point in time, the Earth will help to regulate itself. And their argument would be is that 5 billion of us would die off, because the Earth can't sustain what it currently has. Others a bit more optimistic, up to 40 billion. So we're well short of that. Keep having kids. All right. Now, what we found is this carrying capacity has changed or been modified over the course of time. These are the 3 reasons why. During our agriculture units, in our agriculture review, I'll come back and talk about those more. But Green Revolution, the mechanization of agriculture, as well as expanding farmland, taking land that was previously unusable and making it usable. All right, I'm not going to spend a lot of time on this. You can look this up. Demographic transition, you remember this?
Yeah.
Emblazoned in your head. Okay? Basic principle is this. Population, as it goes through industrialization, eventually has a population explosion before they start to have a slow in terms of their growth rate. 4 different stages. Little population growth, huge population growth during stage 2, falling population growth, but still moderate growth during stage 3, and basically very low growth or even potentially negative growth during stage 4. As you become industrialized in the demographic transition, you see that change. That's what I want you guys to keep in mind. All right? As you move through industrialization, that's when we see our changes. Notice first, death rate drops. During our third stage, our birth rate drops. We talked a lot in my class about the ideas of an agriculturally based society and the belief that you need to have more children. More children are dying because of lack of medicine. So they continue to have more kids, and as medicine is invented and introduced, our death rate drops. Their mentality is slowed to change. Okay? Social and cultural tendencies or traditions are the things that prevent societies from rapidly changing to meet up with their increased industrialization. That's why you get that population boom during the second stage. Right? This one, which I don't know how to pronounce, the epidemiological, that sounds right, the E model. This is a term that's talked about in your terms. If you look at them, I had to research it. I'll be totally honest with you. I've never seen this before. I'm going to say this. I'm going to move through this really fast right now. You can Google this. There's a website. I think it's done by About Geography. If you look up epidemiological transition model, you can find some stuff there. I actually use Wikipedia, which I corroborated with a couple of other sources to get this. Here's what I want you guys to write down and make a note in your notes, like you need to go and look it up. Okay, because you can totally do this, just like I do. The big thing with this model is it looks at the transition of disease and how societies address disease and how that impacts population growth. Okay? So it's similar to demographic transition because it follows on some level industrialization, but the key ingredient, much like, isn't this like the epidermis? Right? Is that right? So the epidemiological model thinks about your skin and disease and whatnot that's associated with it. Make that connection. All right? I've never seen a question like it, but I could ask it. All right? It was on that model. Super important people came up with it. So that's what I want you guys to think about. You can look up the details. All right? But again, the idea is it looks at the transition of disease and how disease impacts our growth rates. Okay? Any disease that occurs. So whether it's disease like the flu, and the flu can wipe out tons of people, versus forms of cancer. And it's a transition that occurs from disease that you and I take for granted because we have vaccines and medicines and stuff for, other people in other parts of the world are dying from because they have lower industrialization, and that affects their growth rate. We're on the other end of the spectrum, so we have all of these vaccines and whatnot, we live a lot longer lives. Right? That's basically the idea behind it. All right? It's a really good slide. Wow, that's really interesting. Mr. Shepherd, I make these things fun. All right, there we go. Okay, population pyramids. No. Really good. This is all good stuff. Very exciting. Okay. They had a question, and I don't think they'll ask a free response question about it, so I feel we don't spend a lot of time on this, but just know, cohorts, right? Notice how we have our ages, we have our gender, and we either have percent or numbers. But notice the differences that exist between all of these. Population growth, Tanzania. The wider the base, okay, the more extreme that base is, the more rapid the growth. Okay? China's population, you'll notice here, this little chunk that exists out of there, one-child policy, super strict. Okay, really slimmed it down. Okay? You'll notice that you start to get this column effect like you do in the United States. Okay? That means we have relatively stagnant population growth. Okay, they're producing the same amount of children as they are. We have, notice how we have, anywhere we have like these exceptions, we call it population bulges. And population bulges in this case refer to like the baby boom generation. You notice that you can also get these really extreme cases. Very large adult population, all right, probably a retirement community, okay, a retirement city. Okay, Arizona, not much else to do there but be in the sun and close to death. Okay, so if you notice you have a very large population group in like the 20 to 24 range, this was a question on there too, could be a college campus. Okay, so you want to think, if you were to get a question like that, what does the data show me? Where are the age ranges coming from? Is it more males than females? If it's more males than females, we could be talking about a Middle Eastern or an Asian country, which tends to favor males over females. So you want to try and put together those pieces as it goes through. Good? I know I got farther than this is probably now. All right, so that's our population. I got 9 minutes. This is perfect. Okay. Movement.